Hello again, Precalc. Sorry about that. I guess I'm splitting this up into two videos. It would it takes a lot of time to splice two videos together. I'm not going to do that, I don't think. So you'll just have in it a video for example 4 and then a video for the rest of these examples if all goes well. Some of my what happened was some of my text got, or my written text got shifted and some didn't. So um, I don't know why that happened. Probably because I didn't let it sync and I kept doing things. It's happened before, but that's why I needed to pause and fix my coordinate plane here for quadrant, or for example 5. So hopefully everything's okay now. If I run into another problem, I might need to pause again. So example 5. So we did example 4 in the last video. I went through that, and I'm going to do example 5 now. Example 5 is another degree problem. 2 cosine theta equals -3 between 0 and 360. It's going to be the same reference angle formulas here. This will change only when it's radian instead of degrees, and we will see that in the next example. I'll have a couple radian after this. The only thing that's well, there's actually a few things that are different with this problem than the last one. But one of the first things we noticed is that it doesn't. In the last problem, we had cosine theta is equal to a number. We didn't have anything else with the trig function on the left side of the equation. Here we have 2 tan theta is equal to -3. This is I don't think anybody's been having trouble with this, but obviously or maybe I shouldn't say obviously, but what you want to do is solve it for the trig function before you do anything else. So I'm going to isolate the tan theta first by dividing both sides by 2. Sometimes they might be a little more complicated, but they're really usually not more complicated than any normal algebra 1 solving equation problem. Not yet. In fact, that is, well, I won't get into that yet, but that is where things get more complicated in. And that's why these are called simple, because it's pretty easy to get the trig function isolated. So the reason these are called simple trig equations, solving simple trig equations, isn't because finding the angles is easy. It's because finding the tan theta is easy. Tan theta, whatever that is equal to, is easy. So tan theta is equal to -3/2. Now we have tangent, and it's equal to a negative. So that's very important, because tangent is negative in the second and fourth quadrants. That means we're going to have solutions in the second and fourth quadrants. So we're going to have 2 solutions as always, and they aren't, what am I saying? Yeah, 2 solutions as always. Oh, yeah. And they'll be in the second and fourth quadrant. So all right, so we're going to put this in our calculator. I think I said everything I needed to there. If not, hopefully it'll come back to me. So we have tan inverse of -3/2. And we're in degrees still. I didn't change anything. So -56.3. -56.3. Now you notice that this is a negative number, and we're looking for solutions between 0 and 360. This is not in that range. Remember, there is an infinite number of solutions for this if you take off the boundaries 0 to 360. So this is a solution. It's just not a solution in the range we're looking for. So the way we do get it into the range we're looking for, because the calculator's just given us something, it doesn't know the range we're looking for. It's actually given us a solution close to 0. Then the way we get it to the range we're looking for is coterminal angles. Every 360 degrees, the cycle completes or repeats, and so we can add 360 to this and get 303.7. If I'm looking at my boundaries here, 303 is between 270 and 360. That's a fourth quadrant solution. Okay. All right, so once I've gotten the theta that my calculator gives me, or a coterminal answer that is, or an answer coterminal to what my calculator gives me, I want to first, or not first overall, but next step would be to find the reference angle. All right, I'm looking for the reference angle. So I have a fourth quadrant solution. I'm going to use alpha equals 360 minus theta to find what alpha is using this as my theta. Okay, plugging in 303.7 and I get 56.3. My reference angle is 56.3, which means that 56.3 plugged into my calculator for tangent would give me positive 3/2. Actually, we can check that out. There's no harm in checking that out. Should give me something close to 1.5. Pretty close. But we're looking for the negative solutions, so that's not one of our solutions, but it'll help us find one of our solutions. Okay, hopefully this is making sense. I know the solution that I'm looking for that I haven't found already is the second quadrant solution. Okay, so second quadrant solution's reference angle, or the second quadrant reference angle, is alpha equals 180 minus theta. I'm plugging 56.3 in for alpha, and I'm solving this for theta. Adding theta to both sides, subtracting both sides by 56.3, and I get 123.7. Okay, 123.7. And then I'm just going to rewrite my fourth quadrant solution, labeling it on the left, and just do a quick summary at the end of the two solutions. Okay. Once again, the process is finding one of the solutions that the calculator gives us, okay, or coterminal to what the calculator gives us, finding the reference angle, using the reference angle to find the other quadrant, the one that the calculator did not give us. Okay, because the calculator is going to give you one solution. It can only output one thing. It's going to give you a solution close to 0. Sometimes that's something in our range, sometimes it's something that's not. But it'll always give us something that if we do coterminal angles, add or subtract 360, we will find something in our range. But it will still only be one solution, and thus a solution in one quadrant, and we have to find the second quadrant, the other quadrant, I should say, because it won't always be the second quadrant. We have to find the other quadrant, and we need to find the reference angle using the quadrant we're given to find the other quadrant. So we're going from the quadrant given by the calculator to the reference angle, then to the other quadrant. Okay. Double checking these answers. So we're looking at let's see here. I'm going to actually go to the top and plug in for theta. So I'm going to plug in 2 tangent and then our solution and see if we get something close to -3 for each of our solutions. So 1, 2, 3, 7. So 2 times tangent, 123.7, should be equal to something close to -3. Pretty close. Good enough because we are rounding. And then 303.7, and also good. Both of them negative, both of them pretty close to 3. Would round up to 3 if we were writing this as a solution, because we go 3 decimal places, that would round up to 9. Well, actually, it would be, I guess it wouldn't round up quite to 3, but very close. Okay. Oh, I don't have the panning tool selected. Makes it so I'm not clicking our cursor blinking around. Okay. Hopefully that makes sense. And so the next one I want to do is a radian problem. So hopefully everything's still in order here. Okay, example 6. We're going to solve 7 cosecant x plus 5 equal to -18, and we changed from a theta to an x, as we do for radian, and now we're between 0 and 2 pi, and we want 3 decimal places for radian. So we had the coordinate plane with the reference angles that we were using for degrees, and now this is the radian formula, quadrants and whatnot, reference angles, but more than just the reference angles. An important part of this is the decimal values between quadrants, because When we're given a measure, an angle measure in radian, we want to know what quadrant that's in. So if we were given 1.7, okay, as an angle measure, let's say, well, we want to know what quadrant is that in. Well, 1.5 is the start of quadrant 2, 3.1 is the end, so it would be in the second quadrant. So what I'm trying to say is I put each of these in decimal form. So that we can more easily see that. 0 to 1.571 is quadrant 1. 1.571 to 3.142 is quadrant 2. And that to 4.712 is quadrant 3. And then quadrant 4 ends at 6.283. Okay? Excuse me. So, again, the first thing we want to do in this problem is solve this for the trig function, add or subtract 5 from both sides. Something got moved here. Subtract 5 from both sides, and divide both sides by 7. This should be shocking to you. So, at this point, we have a cosecant x is equal to negative 23 over 7. And on your graphing calculator, you don't have cosecant. You only have sine, cosine, and tangent, and their inverses. And that's because it's pretty easy to go from that cosecant to its partner, which is cosecant is reciprocal of sine. So cosecant of x is equal to negative 23 over 7. Sine of x will be equal to negative 7/23. So just change it to sine and flip the other side. Cosecant and sine are reciprocals of each other. Secant and cosine are reciprocals of each other. Tangent and cotangent are reciprocals of each other. So sine will be negative in the third and fourth quadrants. Okay, third and fourth quadrants are when sine is negative. So we'll have solutions in the third and fourth. We're going to do sine inverse of both sides, so x will be equal to sine inverse of negative 2/3. Okay, very important. Go over your calculator. Hopefully this will be pretty obvious if you forget to do this, because your answers will be really large, and if you're dealing with radian, you're trying to stay between 0 and 6.283. So I'm going to change this to radian. So if you leave that in degrees and you do this, you'll get degree answers, but we were looking at radian now. And it's negative 7/23, so I'm going to do second sine inverse, negative 7 divided by 23. Enter. And I get negative 0.309, approximately. Once again, it's a negative number. It's not in our range. It's not in our 0 to 6.28 range. So once again, we do coterminal. In this case, though, it's radian, so we're going to add 2 pi to it. And if you add 2 pi, you can actually just take answer plus 2 pi. You'll get 5.974. Now looking at these degrees here, and that's why I was converting this to decimal form, 5.974 is between 7.4 and 6.2. This is a fourth quadrant solution. Fourth quadrant solution. So this is beginning our process that I was trying to make pretty clear now, that goes this way. First, find the reference angle. Second, find the other quadrant that isn't quadrant 4. Okay, first the reference angle, then the other quadrant, because we have our quadrant 4, and that's what our calculator gave us. Well, our calculator won't give us quadrant 3 or a coterminal quadrant 3, so that's the other one we need to find. First, go finding the reference angle to get there. So the reference angle, we're going to use the quadrant 4 reference angle formula, and again, these are now in radians, so it's 2 pi instead of 360. And 2 pi minus x, we're going to fill in for x, the value that we got up here. And our alpha, and I can do this in the calculator, we're going to do 2 pi minus answer. And our alpha is 0.309. Yeah, that's our reference angle. Okay. Now we're looking for the third quadrant solution. So I'm going to use the third quadrant reference angle. Alpha is equal to x minus pi. And I'm going to plug this alpha that I just found in for the alpha for quadrant 3 and solve for x by adding both sides by pi and going back to the graphing calculator. Take your answer plus pi, and you're getting 3.451. Probably rewrite it with the x on the left, yes. All right, so quadrant 4, again, just recapping, was the one I found up here. I have the reference angle. I have quadrant 3, the quadrant 4 that we found before, okay? And just a summary at the end. And we can double check our answers once again. I can do that by plugging these values in for the original. I think it might want to go back to the original again. 7. Well, I can't because cosecant we don't have a key for. So I will go to sine, and let's just see what negative 7/23 is in decimal form. So I want my answers to be close to negative 0.304. And let's see if these work. Hopefully they do, because I don't want to re-record this video. So save face. Okay. What am I doing? Sine, right? This was cosecant, right? Yes, sine. Sine and 3.451, 3.451, and yes, that's pretty close. Negative 3.4. Good. And then sine 5.974. And again, very close to what I was looking for. Good. Just confirming my answers. Okay. I have one more example. This is example 7. Secant x plus 2 over 4 equals 1. Again, it's radian. It's between 0 and 2 pi. We're going to use the same quadrant reference angles, and get some stuff shifted around. And so this is the same one that we just used. I don't need to go through all that again. We're going to solve this for cotangent. Multiply both sides by 4. Subtract 2 from both sides, and you should get cotangent is equal to 2. Cotangent is the reciprocal of tangent. So tangent of x will be equal to 1/2. This is a positive solution, so tangent will be positive in the first and third quadrants. Okay. Take tan inverse of 1/2. Put that in your calculator. Tan inverse of 1/2. Get 0.464. That is a first quadrant solution because it's between 0 and 1.5. Okay, first quadrant solution. So I'm going to clearly label my reference angle. My reference angle alpha is equal to x because it's first quadrant solution. Very easy and nice. And then my solutions, I have my first quadrant, and then I have a third quadrant. I'm going to take the third quadrant reference angle. I'm plugging the value 0.464 in for the alpha, and I'm solving this for x. Okay, I'm going to add pi to both sides, and you get 3.605. 3.605, which should be between 3.1 and 4.7. Okay. Double checking these answers. I'm going to plug in for tangent and try and hope to get something close to 1/2, positive 1/2. So tangent 0.464 should be close to 1/2. Very good. Tangent 3.605 should be close to 1/2. Very good. Okay. So hopefully this makes sense. Now I had handed out a work packet, but I'll put a digital copy up, Google Classroom, and it's 8.2 to work packet 2, that this is a more practice of this type of problem. So thank you and good day.